So the next session, last session of the day, last but certainly not least, will be kind of a slightly more future forward-looking presentation related to the MIPI security specification, which is currently under development. And we're going to learn how the security framework protects automotive SerDes applications from security risks. So without further ado, I'll hand over to Rick to take it away.
Okay, thanks, Ian. So we've been working on this security set of security specifications for about the last 18 months. I hope to give a pretty decent overview of some of the goals, and in particular, some of the kind of distinctive features that MIPI is trying to put into its security for its mainly the CSI and DSI2 protocols. So overview. So we'll give a very high level introduction to what we mean by security and what it means to MIPI, with focus on camera and display. We're going to look at some of the key system and security requirements. An important point is that in the development of these specs, we're trying to kind of maintain a separation, but yet a coupling between system issues. Which protocols, which number of lanes, which physical layers, and then the kind of the, if you like, the hardcore security requirements, which are, where the real security, folks come in. We're going to talk a little bit about the solution details, what the security protocols look like, what they do, and then summarize. Okay, introduction to MIPI security. So, again, kind of big picture. We have sensors, cameras, and we have displays. And then in the center, there's a number of ECUs that are driven by SoCs, typically one or more SoCs. In between, there are bridges. These are well known in the SerDes world for 10 years or so. And the primary reason for SerDes is because the conventional interfaces, C-PHY, D-PHY, DisplayPort, etc., I2C, I3C, they don't work over distances that exceed 10 to 30 centimeters, whereas in cars you need 10 meters or 15 meters, that sort of thing. So the goal of the security work in MIPI, and this will be a focus point today, is it's really tied to the application or the protocol. So the key protocols that MIPI, and including working with Visa, are involved in are the CSI2, the DSI2, as well as the Visa DisplayPort. And essentially, the framework that we set up is that CSI, DSI, and DisplayPort are carried over the long-reach A-PHY. Some of the elements of security we'll talk about in a minute, but they include functional safety, also support for HDCP for premium content. Interestingly, on the very edges, in some cases you'll hear what we refer to as end-to-end, and we'll talk about that. So let's define security. There's essentially kind of 3 steps. The first step is fundamentally you need to authenticate. So what do we mean by authentication? If you look in the diagram, you have a number of sensors, you have a number of displays, you have an SoC, and you have bridges. So what we introduced before. The goal of authentication is essentially to trust the component. So imagine, the old analogy of a printer cartridge. You buy it; it's been pre-authorized for purchase at some agent, and you plug it in, and it takes some time to authenticate, and then there's trust established, so the printer can go ahead and use that cartridge. So in some kind of loose sense, cartridges, as a camera. So after you've authenticated the device, and in some cases, and MIPI supports mutual authentication, so the device would authenticate the SoC and vice versa. So once trust is established, there are 2 fundamental things you do. More importantly, you do message authentication, which essentially validates that the data in motion or the data transitioning the whole network isn't modified. And then optionally, you can encrypt the data to provide, a form of, content protection, which is essentially what HDCP is. So think authentication and then integrity and optionally confidentiality. So essentially, MIPI is trying to, work within this paradigm, the three, think of the CIA analogy. First, you read backwards, you authenticate, then you integrity protect, and then you apply confidentiality. And we're trying to do this from the application level, as I hope to, describe in more detail. This is a standard stack up that MIPI has created. Essentially from the physical layer to the link layer and up all the way to the application layer. By application layer, essentially it's the pixels, pixels that are sourced in a camera sensor, and then ultimately, hit the SoC, and vice versa, SoC up to the display. The functional safety specification in MIPI is complete, has been complete for quite some time. And the focus of this work is essentially to build upon that and add the security features. Again, the security is, considered end-to-end. We'll talk about that. The security work for camera in particular has two specifications. One is called the camera service extensions. Think of these as an update to CSI2, and then a broad MIPI security specification, which is also used by DSI2. We may mention this again later, but the idea is that we'll be finished with these specifications, CSE and the MIPI security specification, around the middle to the third quarter of next year. Okay, look at some of the system requirements and security requirements. It may be this will focus on sensors. There may be another opportunity to talk more specifically about displays as it relates to DSI2 and DisplayPort. So some of the system configuration, some of the system aspects are on the left-hand side. We need to support flexible topologies. We need to support unicast, multicast streams. We have to support multiple sensors talking to one or more SoCs. The notion of aggregation and disaggregation, typically through bridge chips. It must work with and without bridge chips. There needs to be flexibility, essentially to support, the ecosystem of different providers to that ecosystem. Some vendors support CFI, others support DFI. There needs to be a translation from a sensor that might put out one trio of CFI to an SoC that only supports DFI. So this kind of flexibility is built in, and it's essentially serviced by those protocol adaptation layers. I2C and I3C flexibility, even SPI and Ethernet are carried. So the main idea is from a system integration perspective, it fits within the current ecosystem of essentially mobile chips that are being migrated into automotive. Security must be application-based. By that, we mean that it's fundamentally tied to the protocol, CSI, DSI. We also mentioned later that we're working, MIPI and Visa have a liaison to try and do the same thing on the DisplayPort protocol. There's a need for a highly granular set of security options. It's not like a flat security where every packet is treated with the same security association, we call it. On a per virtual channel basis in a camera, there are numerous modes of operation. Well, there's a diagram shown later. Data protection could be applied on a pixel basis, on a per message basis, on a frame basis. There's the opportunity to provide full integrity or partial integrity. We'll talk about that. And then also we've identified or are identifying an entire suite of algorithm options that are suitable for high, low tier components, sensors, mainly sensors. And as mentioned earlier, the whole notion is to have end-to-end security from the pixel source to the pixel sink at the application layer. So when we refer to this picture, we spent a lot of time trying to figure out how do we describe a general framework. We've come up with this framework, this 1 to 5 model. The 1 to 5 are the different components. On the left-hand side, there's the controller or the SoC. On the right-hand side is the target, which is either the sensor or the TCON DDIC. In the middle, there are bridges. There's a forwarding element in the center, not so much specifically for extending the reach, the physical reach beyond the 10, 15 meters. It's really for the aggregation or multicast kind of functions. And on the bottom, we illustrate that, the system and the security must operate with any combination of these components. On the top one, we have 1 and 5 only, so we refer to that as a 1-5 model. When both bridges are present, it's a 1, 2, 4, 5, and etc. Perhaps the most common, scenario, might be the 1, 4, 5 model, where, it's the 1, 2, 5 model, the very low, the last row, where the sensor may integrate the AFI and the data protection, whereas the SoCs may rely on a bridge. So this is the 1 to 5 model. We're going to talk a little bit more, but this was the baseline kind of set of system aspects. Let's talk a little bit about some of the details. So we have the 1 to 5 model, and again, the goal is to have end-to-end protection. By end-to-end is typically meant 1 to 5. So the intermediate entities 2, 3, 4 essentially can do nothing as relates to security. However, if the number 1 and 5 are unable to support security, then that function can be moved onto components 2 and 4. As usual, there's in-band security. There's 2 modes of that, SEP, FSED, we'll talk about that. And then there's sideband security. Sideband security is primarily for cameras that rely on I2C control. And when we get to doing the similar function, security function with Visa, they have a DP-aux line which would need to be protected. And we're hoping that model, will extend. In terms of the data protection methods, SEP is a service extension packet. So imagine a CSI2 packet that's protected with SEP. This is message-based. In other words, it protects individual CSI or DSI messages. Again, it could be end-to-end, could be link-based. I'm not going to spend too much time with link-based because our focus is on end-to-end. FSED is a purely frame-based data protection elements. So imagine a 4K image. Essentially, the data protection would be applied on a frame basis. Whereas the previous one, SEP, is with more computing work, you can essentially protect every message. And there are some pros and cons, depending on the application. As far as I2C or a camera control interface, we've defined this as enhanced safety and security, CCI. This is, again, kind of transaction-based or message-based. So essentially, this kind of gives a framework of the in-band security as well as the out-of-band or sideband security. And again, there's flexibility, and as we mentioned earlier, from a system perspective, the controller, the 1-2 interface might be in the display case, the 1-2 interface might be DSI2, but the end input to the target number 5 may be a display port. And vice versa, if it's a camera scenario, number 5 may put out C5, but number 1 may only accept D5. And then the number of lanes may change, etc. And these are supported within the within the framework. A little bit more detail. This is, we call the framework 1 to 5, ABC, 0 to 6, and let me walk through those 3 kind of dimensions. If you look at the layering from bottom to top, we have the data security services. That's kind of like the meat and potatoes that does the encryption, it does the message authentication. It needs keys. It needs secure sessions established, and that's done by the layer above it, the B layer, which we call System Security Management, SSM. We refer to the suite of protocols there. Some of them are MIPI, some of them are borrowed, leveraged from DMTF. And then above it is a provisioning phase where essentially, a couple ways of doing it, but essentially the OEM or the integrator would essentially push certificates or shared keys down. And then, the handshake occurs and the secure sessions are set up. So kind of big picture, we understand, the 1 to 5 components. We have the 3 layers ABC. MIPI's only current thinking is that we would only specify A level and B level. C level we'll leave open. We're imagining some kind of API between B and C. So that's kind of the makeup of the framework. Again, from a top-down perspective, and this is where the 0 to 6, these are the steps involved. 0, the integrator provides the authentication credentials. And then there's a series of steps that set up the handshake. Different scenario, but somewhat similar to HTTP, how it distributes keys. First sets up a secure session and then distributes keys that are used in the A layer down below. If you're more familiar with Ethernet, there's a particular authentication protocol, and then the meat and potatoes on the bottom, if you like, operates the MACsec protocol. The MIPI chose the handshake protocol from DMTF. It's the SPDM protocol, and has supplemented to meet the particular MIPI requirements. A good analogy is that MIPI Security chose the TLS model for setting up secure sessions, which is essentially done in every web browser. So this is kind of the big picture. We're working on primarily levels A and B. We're spending quite a lot of time going through the operational steps, so the 0 to 6 end of things, in order to kind of improve kind of understanding. This is the first time that there's been a standard for end-to-end security for SerDes implementations. So we're trying to be very careful with how we kind of imagine the system. Okay, this is a little bit more detail on the SSM suite. I'm not going to go through all of it. And a very important point is the first one, which is its controller-driven communications. This is very reminiscent of a mobile architecture. Essentially, there's one, in mobile speak, there's an AP, application processor, that typically is in charge of and responsive to all other components, kind of like a hub and spoke model. So that's kind of the baseline assumption here, that there's one controller and it communicates directly or indirectly through bridges, with the targets, sensors and displays. There's a handshake that's set up, initiated by the controller using the authentication keys from the C layer. And then after the handshake is complete, and there are secure sessions set up between components, in other words, a secure session between 1 and 2, 1 and 3, 1 and 4, 1 and 5, in addition to secure sessions set up between any 2 components that talk to each other. So essentially, that's kind of a centralized, point. It's not to say that there's only one controller available in the model. We'll talk about some of the topology options next. Before we get to the topology, we wanted to clarify a little bit about some of the discussions surrounding link-based versus application-based security. Both of these are well understood in the industry. You can see that in the link-based layer 2, essentially it operates at the link layer and encompasses the PHY. So if you imagine this OSI layer stack, you can imagine that the right-hand side differs from the left-hand side in that the end-to-end, which is common to both left and right, essentially extends in the right up to the application protocol, layer 7, if you like. So essentially, it provides protection from CSI2 source to CSI2.6. So in this case, from the camera, to the SoC. In the link-based security, of course, this is very well understood for many devices. Obviously, whenever you're in a local area network, you'll use MACsec, and this is a great protocol. It's well proven, works great. If you do want to support particular application level security, then you need another protocol, whether it's IPsec or TLS. So both of these security methods are or can be end-to-end. It's just a question of how high up the OSI stack they reach. Okay, topologies. So we have two SoCs on the left. We have two cameras on the right. You can see that the upper right camera will, in the thick black line, will send its data into a bridge. The bridge will split or multicast two different bridges on the other end, and then they go to two different SoCs. On the lower right, the lower camera sends it essentially to the lower SoC. That's a unicast. In terms of security configuration, you need one kind of central root of trust. In the picture, we assume it's the upper left controller. SSMC is, as shown in the bottom, is System Security Management Controller. So imagine controller target. We're trying to use the same terminology that MIPI is adopting in other specs. So the root of trust, the nominal root of trust, SSMC1A, would distribute keys and other things essentially to all the components, including the second SoC. So this topology in the model, security model, supports unicast, multicast, multiple SoCs, multiple cameras, multiple displays, daisy chain displays. So essentially all the things that you would want to support from a system integrator perspective. And again, on the upper part of the portion, you can see that this is a 1, 2, 4, 5 model with both bridges present. In the T bridge number 4, there's an aggregation function, and that allows fewer numbers of bridges on the kind of the camera side of things. So this is more of a topology view. In terms of complexity and cost scalability, so the sensor manufacturers in our security meetings have really identified a need to try and scale the amount of security processing that occurs, in the sensor. Similarly, on the SoC side. So as an example, you can see that the upper example, and what we call MAC mode 1, applies data protection on a per message basis. So imagine every CSI2 packet. And then similarly, there's one MAC that's computed and then transmitted on each line or on each message. And then as you go further down, what we call MAC mode 1.5 is a per multi-message. So imagine accumulating the MAC over multiple messages. And then it continues throughout the frame. So multi-message per multi-message. And the implication, of course, is that you're sending fewer MACs in the frame. The third one is a per frame MAC, where essentially the MAC engine will accept all SEP messages in the frame. The very last one is a relatively new one, which is essentially, it doesn't operate on messages, it operates on pixels. And this is the most end-to-end, if you like. In some sense, it operates above the CSC or above the CSI2 layer. There is no CSI2 involved in it, it's just the raw pixels. Again, in performance, you can imagine that AES GCM, which is used, pretty much everywhere for, more complex scenarios of security, it can be scaled down to kind of lower, less computationally expensive methods, such as, separate CMAC, and then followed with a separate AES counter mode core for encryption. So this just tries to illustrate, the suite of, performance requirements that are being built into the security spec. So in terms of summary, MIPI is developing an industry standard to protect sensor and display data streams. This includes, of course, the control aspects. MIPI is also liaising with Visa to develop comparable mass security for DisplayPort. The DisplayPort protocol is very different from CSI, DSI, but essentially the main, the model fits. There is a strong requirement to have DSI and DisplayPort operate in a seamless fashion in a car, essentially across a daisy chain. So, the primary effort is to make sure that it's done in a similar fashion. So that's essentially the purpose of the liaison to work jointly. Maybe CSI2 security for ADAS provides a system level solution. It's application-based, it's end-to-end. MACsec is well understood. There's some kind of, in some sense, some controversy. There should be no controversy of MACsec versus TLS or the one MIPI chose. Essentially, they're doing different things. Because MIPI has chosen to operate at the application level, there was a necessity to scale across the different tiers of sensors, to provide very granular security controls in the specification. And again, all of the communications are protected at this, application level. Security is initially targeted for automotive, but it's applicable wherever CSI2 goes. So, some of us joke, if you like CSI2, you're going to love CSI2 security. The MIPI security version 1 and the CSE version 2 specs are targeted for third quarter of next year. Of course, we welcome, during the security meetings and the related functional safety meetings, we have very good attendance. Any broader perspective on the specifications, particularly some of the system level details, is very welcome. You can contact MIPI, to reach in. And then we are currently planning a MIPI security workshop in January of next year, where we'll have a number of different speakers go into a little bit more detail, on the solution and probably some of the opens that we see, again, mainly from a more system perspective. Okay, I think that's all for the presentation. Back to you, Ian.
Okay, thank you, Rick. Great presentation. Lots of very detailed information there. Obviously, audience, please submit any questions via the Q&A box, and we'll do our best to address those. Just a quick one, perhaps to get us started. Rick, you mentioned link layer security versus application layer security, and I just wondered if you could perhaps expand on the pros and cons of each of these approaches and why MIPI is perhaps focused on the application layer.
Right. So, with kind of a broad stroke, MIPI does a couple of things well. It develops physical layers, the Fuais. It also develops protocols. Essentially protocols are where most of the action is, from the perspective of integrators and making sure that all the requirements are captured. So in some sense, it was just a very natural place to go to. And when we were evaluating the set of protocol options, essentially, some of us immediately went to TLS. That was a little bit heavy, if you like. And it was very natural to, and then of course we found the MTF org, and they were essentially developing the SPDM specification, which is a lighter version of TLS. So in some sense, it was a very natural place to start. And of course, by application-based, it covers any physical layer underneath. So in some sense, it was a superset of a link layer based security. So yeah, I think, part of, I would say, MIPI's strength is in the protocol. So that was the motivation.
You mentioned there, obviously, the MIPI security specifications that are looking to be based on DTMF and SPDM. Can you talk about, how kind of those that they were selected, kind of what process perhaps the group went through to kind of end up selecting those protocols?
Mm-hmm. Yeah. If you when we started to look at the the topology, it was very reminiscent of how PCI Express works in compute and servers. There, you don't have bridges, you have switches. A lot of the participants in early discussions in MIPI, also participate in other organizations where that topology is well understood. And very similar discussions, link-based versus end-to-end. In PCI Express, for example, you don't necessarily have the as explicitly defined the application layers. But it was largely, from cross membership in different orgs and understanding that the topologies are very similar, and that's what prompted, a deeper look. And once SPDM was internally decided, or at least recommended, there was some scrutiny, outside to a broader MIPI membership, and that's what we ended up with.
Okay, yeah, thanks, Rick. That makes sense. A natural fit. Obviously, in your presentation, you ran through the kind of security framework. You talked about the 1 to 5 model, the ABC, 0 to 6. Why is there this need to kind of, define the model in such detail?
Well, yeah. Well, essentially, we wanted. I think ultimately it boils down to, folks understanding how the system works. Some folks are all into CFI, others are into DeFi. Some folks haven't yet adopted I3C. So there's a number of system issues. And we wanted to kind of, and SerDes, this end-to-end security, I think I mentioned this, the end-to-end security model in SerDes is very new, especially the application, centric perspective. So I think it was essentially to kind of help people understand what we're doing and then build up, some kind of ecosystem that would, that would contribute to make it better. So, again, it's something new, and we wanted to make sure it was well understood.
It certainly is. It's very, very clear. Just to sort of focus on the 1 to 5 model, you have this element in there, the A5 forwarding element. I must admit, when I first saw the framework, I was like, what's this A5 forwarding element? It's kind of, surprised me to see it. That's because I think it's always been there, but perhaps you could just tell us a little bit more about it, because it's probably an element that perhaps others are kind of not aware of, so to speak.
Yeah, so the forwarding element is not, so typically SoCs and bridges and camera sensors are, if you like, they're single chip or single module. By forwarding element, we don't necessarily mean a chip. It's essentially just a function. So in the topology picture, there was a multicast example, and in that case, that function is essentially a forwarding element. So it would take in a stream from a camera, and it would duplicate it, and then send it out to separate endpoints. So that function of kind of replicating is essentially served by a forwarding element. So forwarding element is essentially built into those aggregators, or those multicast elements. So it's typically not a separate chip.
Yeah, I think that's why it's got confused. I thought it was a separate component, but it's this logical entity.
Yeah, it's a logical component. Yeah.
Okay. Again, looking at this, the security framework that you put together, I mean, can you give any kind of comment about how heavy the security framework is? Obviously, some security frameworks are very heavy. They had a lot of overhead. What about the MIPI framework? Does it add a lot of overhead to the data traffic?
So, right. So I guess one element of heavy is the fact that by using different, what we call MAC modes, you're able to kind of lighten the burden on the sensors. So you need not necessarily compute a MAC on every message, but in the limit once every frame. So that's a level of kind of downgrading the requirements on the sensor. So that's kind of more from the A level, from the kind of meat and potatoes, encryption and integrity protection. In terms of the handshake, if you look at the progenitor, the TLS handshake, it's somewhat complicated. SPDM lightens the load in some sense. There's always handshakes to be done. HTCP does it. The MACsec has their own. And it's just the nature of the game, that you do need to provide a handshake. In terms of quantifying it any differently, we probably have to get a more security person to quantify it. I'm just not that security person. I think we'll take that as an action, for the January, presentation to try and quantify it a little bit more. It certainly does exist. I'm just not the guy to, present it now.
Okay, no worries. I don't want to put you on the spot there. Obviously, we're coming toward the end of our session now. You mentioned the kind of desire to do a future workshop. Can you kind of give any kind of more flavor to kind of why, the security group wants to have that industry engagement and kind of what they'd like to get out of that interaction with the wider industry?
Mm-hmm. Right. So essentially, it's to get feedback on the specification. I would say that we have a core group of about a dozen members from actually a broad group of companies, 6 to 8 companies represented. It's just a question of kind of going into more detail. We've been thinking it may be possible to pre-release an early version of the specification in some way. So it's essentially to give exposure in more detail than these kind of fluffy PowerPoints. It's to present more detail and get feedback.
Okay, Rick. Okay, there are no last questions from the audience. I think we can probably wrap up this session, Rick. So all I can do is thank you once again for your presentation, and thank you again for answering those questions. And obviously, if people are looking for more information, perhaps that's the last question. If people want more information, how do you recommend they engage and find that, Rick?
So I think it was in the last slide. There was some reference. I think it was admin@mipi.org. I forget what it is. Admin@mipi.org for more information. I mean, feel free to, to also reach out to myself or Phil Hawks, who are the co-chair of the security work group, and we'll be happy to kind of absorb it and do the right thing with it.
Okay, thank you. Okay, so we can close down this session, and it's probably up to me now just to kind of wrap up for the day. So I've got some observations written down here. What struck me throughout today's workshop is how much work MIPI has done in the automotive space. Everything you've seen today has kind of been the product of several years worth of hard work by numerous working groups within MIPI. So I hope you can appreciate how much work's gone into getting to this point today. Second point of note here is how MIPI with the MAS framework provides a full stack solution for the automotive market, particularly for camera and display applications. I think that's really sort of key attribute that MIPI brings to the automotive industry is the fact that we've got all the bases covered. You can see that right from the physical layer, the link layers, the adaptation layers, the higher level protocol layers, the control interfaces. It's all there, and therefore should provide a very compelling solution, end-to-end solution for automotive applications. Another key point I observed today is that MIPI is reusing a lot of specifications in its automotive framework. The camera specification CSI 2, the display specification DSI 2, and all the sort of companion specifications that go along those with those specifications are largely being taken from the mobile industry and reapplied to the automotive industry. That obviously brings tremendous economies of scale with it. Not having to reinvent the wheel, and really the MAS framework really just fills in the key gaps around again functional safety security the automotive market wants. So I hope that was a clear message coming through in our workshop today. Obviously, we mentioned functional safety and security throughout the day. Hope it's very clear that we've done our utmost to make sure the MIPI specifications, the MAS framework satisfies the most stringent functional safety requirements and in the near future security requirements. Hopefully, you've also taken away that MIPI supports our developers with application notes. You saw the presentation from Raj on the A5 system model. You also saw the presentation from Ash talking about the test suites that MIPI produces. They're all really important, valuable tools to help implementers of our specifications. So hopefully you've taken away that information today. In terms of how to find out more, obviously we have a MAS white paper, and I'm just going to literally post into the chat window the link to the MAS white paper. Obviously, that a high-level document, you know, it's quite a quick read, just 25 pages, but really brings all we've discussed together, all we've discussed today together into one place. So if you're kind of unsure about how the MAS suite of specifications fit together, please download the white paper. It will explain it all. Then come back to the most sort of practical measures today. Obviously, we run all of our sessions live today, but we'll get the recordings posted onto our YouTube channel ASAP. You can already download all the presentation material from the MIPI website. If you look under our Knowledge Center, you'll find all the presentation material. Rick just said, you know, please reach out to us. We're a very approachable group of people, and we will do our utmost to respond to you. You can use the admin@mipi.org email address. That'll come through to myself and my colleagues here at MIPI, and we'll respond back to you. But feel free to reach out to any of the speakers today as well. And I suppose the final note, we've got more to come in 2022. It doesn't just stop here. This is really just kind of the first base with regard to MAS. 2022, very early in 2022, in January, we'll be releasing AFI 1.1. Rick mentioned the security outreach. We'll be having a workshop on the security specifications again in January, February, and we'll also be opening up to input from the wider industry into the future releases of the AFI specification. So again, keep an eye open for that. We'll be organizing a workshop on the future of AFI and looking to capture the next requirements for that specification. Okay, I think that's probably enough from me and probably enough for today. Hope you've enjoyed it, and thank you to all our speakers today for their wonderful presentations, for taking the time also to answer so many questions, and obviously thanks also to the team here at MIPI that made this possible today. It's a tremendous effort to bring this all together and run it as this one smooth package. So thanks to the rest of the MIPI team for doing that. And most importantly, of course, thank you to all of our attendees for taking the time to tune in and listen to our sessions today. Okay, that's it, I think. Thanks a lot. Goodbye.